Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on the law of definite proportion and the law of multiple proportion. In our last lesson, we learned about the law of conservation of mass, which was first discovered by French chemist Antoine Lavoisier. We learned that mass cannot be created or destroyed in a simple chemical reaction. So, the mass of reactants is always the same as the mass of a chemical reaction's product. Everything that exists has always existed, and everything that exists will always exist. Today, we are going to look at two more laws: the law of definite proportion and the law of multiple proportion. The law of definite proportion states that a chemical compound always contains the same proportion of elements by mass. This means that all pure samples of a compound have the same composition, no matter where the samples come from. This law is also referred to as Proust's law, because French chemist Joseph Proust was the first to observe the law. He did so during experiments he conducted between the late 1700s and early 1800s. Water, for example, always has a chemical makeup of H2O. Two hydrogen atoms for every oxygen atom, regardless of whether the water comes from a lake, a faucet, or a bottle. In other words, the ratio of the constituent elements in a compound never changes, regardless of where you find your sample. With H2O, the same proportions of hydrogen and oxygen remains. Water is made up of 11.2% hydrogen and 88.8% oxygen, a ratio of 1 to 8 by mass of hydrogen to oxygen. So, according to the law of definite proportion, a pure sample of water from anywhere in the world will always contain hydrogen and oxygen in a ratio of 1 to 8. The 88.8% oxygen was divided by 11.2 and rounded to the whole number 8. And the 11.2% hydrogen was divided by 11.2 and rounded down to the whole number 1. Teacher, if students have questions on how to reduce percentages to a ratio, would you help them after our lesson? Thank you. Students, let us do an activity from the textbook. Zinc oxide is another type of compound. It is used in many materials such as glass, paint, and plastic. Zinc oxide has 80.2% zinc and 19.8% oxygen by mass. Please write this compound down as a ratio as we did for water.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. How did you do? If you came up with the answer 8 to 2 or 4 to 1, then you are correct. The ratio of zinc to oxygen in zinc oxide is 4 to 1 by mass, regardless of where in the world you find it. Let us move on to the law of multiple proportion. This law states that when two elements combine to form more than one compound, they do so in a ratio of simple whole numbers. English chemist John Dalton first discovered this law in 1803. Just like with the law of definite proportion, the law of multiple proportion is less concerned with specific mass and focuses more on mass ratios. If two elements can form more than one compound, the ratio between the mass of the second element in one compound and the mass of the same element in the other compound will be in simple whole numbers. Carbon and oxygen are a good example of this. They react together to form two compounds, carbon monoxide and carbon dioxide. We would say the reaction of carbon and oxygen forms CO and CO2, not CO and CO 1.3, as 1.3 is not a small whole number. And in the two compounds, the mass of carbon is always the same. There are 2.67 grams of oxygen in carbon dioxide and 1.33 grams of oxygen in carbon monoxide. By comparing the two, we find that the masses of oxygen in the two compounds are in the small whole number ratio of 2 to 1. The mass of carbon in both carbon dioxide and carbon monoxide is the same. Let us do another activity. Compare the mass of oxygen present in dinitrogen trioxide, N2O3, and dinitrogen monoxide, N2O. What is the ratio between the two masses of oxygen?
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. How did you do this time? If you came up with the answer 3 to 1, you are correct. There is actually quite an easy trick to see the ratio. If we are comparing the 3 oxygen molecules in dinitrogen trioxide to the 1 oxygen molecule in dinitrogen monoxide, the ratio of oxygen is 3 to 1. To recap this lesson, we learned that pure samples of any compound will be the same, regardless of where you find them. This is the law of definite proportions. We learned that French chemist Joseph Proust was the first to discover this law. We have also learned that when 2 elements combine to form more than 1 compound, and the same amount of the first element is used in each, the ratio of the amounts of the other element will be in simple whole numbers. This is called the law of multiple proportions. It was first discovered by English chemist John Dalton. We finished our lesson by comparing the mass of compounds to form ratios. This brings us to the end of today's lesson. Until next time, thank you, teacher. Thank you, students.